This video is on the fundamental theorem of calculus. Up until now, we've seen two major branches of calculus, the differentials, which was the tangent line problem, and integrals, which is the area problem. Leibniz and Newton independently discovered a connection between them and stated informally that differentiation and definite integration are inverse operations. So getting to the real meat of it, the fundamental theorem of calculus says this: if f has an antiderivative of capital F, then you can find it this way. If a function f is continuous on a closed interval, and f is the antiderivative of that function on the interval from a to b, then the integral from a to b of f of x dx is simply capital F of b minus capital F of a. When applying the fundamental theorem of calculus, follow the notation below. The integral from a to b of f of x dx is equal to f of capital F of x with the limits of a to b, which simply means plug in your upper limit after you find your antiderivative and subtract it from the antiderivative with a plugged in. So let's do some examples. Example 1. Graph y equals 2x on the interval from 0 to 6 with a calculator. Let capital F of x equal to the integral from 0 to x of 2t dt, and this will be the accumulated area under the graph of the function. So they want us to complete the chart below. If I had a calculator, I would show you what it would look like, and we can actually do this in class tomorrow. However, 2 to the x is a line, so if we're going based on the integral from 0 to 0, well, we haven't really gone anywhere. So the area of that would just be 0. From 0 to 1, we'll have a trapezoid or a rectangle. Finding its area, that'll give us 1. If we substitute in 2, that'll end up giving us 4. 3 is 9. 4 is 16, 25, and 36. So next question is asking us, what relationship do you see between x and f of x? If we look at just the table, you've got the values of a quadratic function. So the relationship between these two is are perfect squares. And so it appears that the integral from 0 to x of 2x dx, the integral from 0 to x of 2t dt, is really just, if we take the integral of 2t dt, that's really, we're going to use the power rule, so it's 2t squared divided by 2 from 0 to x. If we simplify that, that's just really t squared from 0 to x. And if we apply the fundamental theorem of calculus, that's saying x squared minus 0 squared. 0 squared is just 0, so we end up with the answer to be x squared. Let's do some more examples. Example 2, find the value of the definite integrals. So again, power rule tells us this would be x to the 4th over 4, going from 1 to 3. Using the fundamental theorem of calculus, we substitute in our upper limit first. So that's 3 to the 4th power over 4 minus 1 to the 4th power over 4. Using some algebra, we simplify this, and that would give us 20. Next one would be x cubed over 3 minus 3x, going from 1 to 2. Substitute in our values. 2 cubed over 3 minus 3 times 2 minus 1/3 over 3 minus 3 times 1. That'll give us negative 2/3. If we change this, this becomes 3 times x to the half dx from 1 to 4. Now we can integrate using the power rule. We'll have 3 times 2/3 x to the 3 halves from 1 to 4. Use the fundamental theorem of calculus, substitute in our upper limit and our lower limit, and that would give us 14. Your favorite part in the whole world, trig functions. You integrate them, that'll end up giving us tangent of x from 0 to pi over 4. Substitute in your values. That'll give us 1. Here, we need to FOIL this in first before we integrate it. So that's from negative 1 to 1 of 4x squared minus 4x plus 1 dx. Now you integrate it. That would give us 4x cubed over 3 minus 4x squared over 2 plus x, and all of it being evaluated from negative 1 to 1. We substitute in our values, and that would give us 14/3. Here, we integrate. So the integral of sine is negative cosine x plus x, and we're going from 0 to pi. Substitute in the values, and we end up with pi as the final solution. Here, we're going to split it up into the integral from 1 to 8, square root of 2 over the square root of x dx. Pull out that square root of 2 and bring in the square root of x up. So that'll give us square root of 2 on the outside, the integral from 1 to 8 of x to the negative half dx, and then use the power rule to integrate it. So we'll have square root of 2 times 2x to the half being integrated from 1 to 8. We substitute in our values, and that gives us 8 minus 2 square root of 2. The last one, we're going to distribute square root of x into x and into negative 2. So then this becomes the integral from 1 to 4 of x to the half minus 2x to the negative half dx. We integrate it. That'll give us 2/3 x to the 3 halves minus 4x to the half, and we're evaluating it from 1 to 4. Substitute in the values, we end up with 2/3. And the last example. Now we're talking about absolute value. If we were to draw this out, we know that the sharp corner occurs at x is equal to half, and we get that by setting the inside equal to 0. They want us to integrate from 0 to 2. So if we substitute in 0, we know that our y-intercept would be at 0, 1. And it goes up to 2, and that value would be 2, 3. So just like definite integrals, use the area formulas and we're good to go.